Exponential growth and decay in 5 minutes. An exponential growth or decay word problem is just an extension of the standard exponential function formula. But instead of calling the initial value A, we sometimes call the initial value capital P. Mostly because we're talking about money or an initial population. And so P usually stands for the principal or the beginning amount. And the B, which is the base or the rate of growth or decay, generally is a percentage. So when you have your entire initial value, you have 100% of your number. We call that 1 or 1.0, right? So if you have 100% of your number and you are growing, then you're going to add something to all of your value. If you are decaying or decreasing, you're going to subtract from that 100% the amount you are decaying. And that amount is known as the rate, so we refer to it as R. And the length of time is generally our variable or our X value. And that's why we represent it with the letter T. So P for the initial amount, R for the rate of change, and T for time. Now, we have inside the parentheses here a plus or minus sign. If there's a plus sign, it's growth. If there's a minus sign, it's decay. And sometimes there's no sign at all. And you have to determine if that value in here is greater than 1, it's growth. And if it's less than 1, it's decay. Let's take a look at an example. The original value of an investment is $1,400. We call that the initial value, also known as the principal. The value increases by 9%. Now, a rate cannot include the percent sign. So if it cannot include the percent sign, then we need to take this value and write it as a decimal, 9/100ths, or 0.09. So that is our actual R value, not the digit 9 with a percent sign. As we continue to read, we can see that the investment grows for 25 years, so that will be our T value. So now that we have all of our values, we have to choose either a growth or decay formula. Well, since we know that we are increasing, we are going to choose a growth formula, which means that I will erase and replace the P, I will erase and replace the R, and I will erase and replace the T. So my principal amount is 1,400. My rate, without the percent sign, is 0.09, and my T value, or length of time, is 25. Now, I can either type this into my calculator exactly how I filled in the formula here. I can type the parentheses, the 1, the plus sign, etc. Or I could actually add that 1 and 0.09 together. So here's what I mean. Once I press parentheses, I can type the actual addition sentence like this and raise it up to the power of 25. Or I could have done a little bit of mental math and typed the answer to 1 plus 0.09 without the plus sign and raise it up to the 25th power. It's up to you how you choose to write it in your calculator. But typically when you write the exact formula, translated the way you initially did, you avoid any errors. Now, because we're talking about money, we're going to round to the hundredths place. So $12,072.31 is how much the investment will be after 25 years. Let's try another problem. The value of a car is $18,000 and it is depreciating. Depreciating means to decrease or decay. Depreciating at a rate of 12% per year. Use this exponential function to determine the value of the car after 10 years. So the principal is the starting amount, which is $18,000. The rate of decay is 12%, also known as 0.12, and the length of time is 10 years. Now you can type it into your calculator as 18,001 minus 12%, or you can choose to perform this difference and write your function as 0.88, right? Because 1 minus 0.12 is 0.88. And this is how I know it is decay, when the rate is below 1, right? Between 0 and 1 is decay. So you could type that into your TI-84, and once you compute, you will get your value. Because it's money, we're going to round to the nearest hundredths place. So $5,013.02. Don't forget the dollar sign goes in front of the number. Let's take a look at a few Regents questions. Kathy plans to purchase a car that depreciates, loses value, at a rate of 14% per year. If the initial value is $21,000, which equation represents the value after 3 years? Well, you notice they all start with 21,000, so I don't even have to think about this. What I really want to focus on is the fact that this depreciates. That means that the R value has to be less than 1. So this one is out. I also know that this is decreasing at a percentage rate, so this must be an exponential function, which this one is not. So far I know that 3 and 4 are not possible. Now the question is, what should my base value be? Now remember, in the other formula we had a 1 in the front of that R rate. So we can't just put a 0.14 and not include this 1 value. Because we are depreciating, it is 1 minus 0.14, which is where we're getting this 0.86 value from. That is the correct answer. You could set the problem up yourself. You could compute this value here. And that is how you'll find your match. Let's take a look at this one. A high school sponsored a badminton tournament, and after each round, 1/2 of the players were eliminated. If there were 64 players at the start, which is the initial value, which equation models the number of players left after 3 rounds? Well, we are eliminating 1/2, so we need a minus sign. So these are out. Now, the 3 rounds is the length of time, so we really want to focus on that exponent. The answer is option 1. Initial players is 64, decrease of 50%, that's 1/2, and the length of time of 3. Jim uses this equation to find the amount of money in an account. For this equation, which phrase describes the yearly rate of change? Well, take a look. That's a plus sign. So we are increasing. Now be careful. This value is the percentage rate. It currently does not have the percent sign. In order to put the percent sign back in, you would need to move this decimal 2 places to the right. So the percentage of growth is 5%, not this decimal number. Remember, this number doesn't have the percent sign, so we'd have to change it to put the percent sign back. In this question, you're asked if you have growth or decay. Again, in looking at this value, we know it's decay, so we can cross off these 2 options. Because I am decaying at a rate of 0.2, right, I could compute this to get the answer 0.88, which is where this is coming from, but that is not how much I'm losing. I'm losing 12%, so the decay is 12%. In this example, you're asked to determine what the percentage of change is each year and to explain how you arrived at your answer. Well, the percentage of change is 0.95, But because that number is less than 1, that means we have decay. Decay is described as the amount that you are less than 1. The amount that I am less than 1 is 0.05. As a percentage, that is 5%. So when I explain what is the change each year, I'm going to say it decreases 5%. Now you can explain how you arrived at your answer by saying the rate of decay is less than 1. 1 minus 0.95 is 0.05, which is 5%. This last question asks you to explain what the value 0.5 and 300 represent in this scenario. We're talking about a chemical compound, and this is the equation that represents that chemical compound. It represents the number of milligrams of the substance over a specified time of year. So 300 is the initial amount of chemical in milligrams. And the 0.5 is the 50%, right, because this is not a percent yet, is the 50% decay rate. Or you could say rate of decay. So we say initial amount, that's explaining, and we say whether it's growth or decay.